Now, question 1c is very interesting. It's a DC circuit with inductors and capacitors in it, so it's stimulated by a DC source, which is, in this case, a current source of 6 amps. Okay, so that's the current source here, 6 amps, and we have inductors and capacitors in it, and we are supposed to find the branch current I through the 24 ohm resistor. Okay, so how do we tackle this? Well, there's something that you've got to remember with regards to inductors and capacitors. It's kind of like a property of how they operate when they are exposed to DC. So after they've stabilized and so forth in terms of how much energy they're going to absorb and whatnot. So let's consider the inductor. Okay, we know that the inductor is V is equal to L di dt, right? Well, what happens at steady state? The change in current goes to 0, okay? And the voltage across the inductor therefore has to go to 0. So it appears like a short circuit, okay? There's no voltage across it. So we replace the inductor with a wire, okay? So this is meant to be an inductor symbol, okay? So what about for capacitance? I is equal to C dV dt. So after a long time, the capacitor is going to stabilize, right? And there's going to be no more change in voltage. So that's going to be 0, okay? And then I will have to go to 0. So when the current is 0, then the capacitor is going to appear like an open circuit, okay? So then what do? So let's redraw the circuit the way that it looks. So we have our current source here, 6 amps, comes all the way around to this 24 ohm resistor, and we want to find this current I. Okay, so now this inductor, let's say the 6 henries, that's going to be replaced by a wire. It's going to come down to this 20 ohm resistor, and then this 30 ohm resistor will still be here, 30 ohms, and then it's going to go down and through the 3 henries inductor, which is going to appear like a wire, and the capacitor is going to appear like an open circuit. So let's just for fun draw where those components were. Okay, there was an inductor here, and then a capacitor here. But with the DC source, capacitors turn into open circuit and inductors turn into short circuits. Okay, so this is just turned into a simple resistive circuit now, and we can use a current divider to solve for it. So let's go ahead and do that. Let's say to solve this, we can only use the current divider if there's only 2 branches. So we got to collapse this branch to become one branch, and we could use parallel rule because these resistors are in parallel. So this R equivalent is going to be 20 ohms times 30 ohms divided by 20 ohms plus 30 ohms. Okay, and that works out to 12 ohms. So then let's use the current divider. So current divider, and that is that I, okay, I. Now when we use the current divider, we use the resistance of the other branch that we're considering, so we have to use the 12 ohms, okay, so it's going to be 12 ohms plus 24 ohms, that's the branch that we have the I current in, and this is a scaling factor to the total current coming in, so that's 6 amps. And then if we do that calculation, we get 2 amps. So that is our answer, 2 amps, so that's what we put up here, 2 amps.